So the hypotheses will again be always centered around my claim. Notice everything here says claim, 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 claim. And it's always written in terms of the population. Notice mu, 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 mu. Never X bar. Some of the problems will mess with you a little bit, and that this could be a greater than or equal to, but the null hypothesis always contains an equal to. I mean, I could write one that doesn't, but 99.9% of the time it'll always contain equal. And like I say, every once in a while it could actually be a less than or equal to. Wouldn't be on this one, but on the other version down here, this would be a greater than or equal to one. So they might mess with you on the AP test. By and large, they'll always be equal to in the null hypothesis. So now we have three different versions for the alternative. Either I think it's less than the claim, or I think it's greater than the claim, or I'm really undecided, so I just say not equal to. It's different from the claim, or not the same as the claim. And then the next piece after the hypotheses is the calculation. And so there are different avenues. This is why we're going to use your template and do it three different ways. And they are, one is I calculate the test statistic, which is either my Z or my T, and I compare that to the critical value, which is either the Z star or the T star that you've already been looking up. Second option is I can calculate the same test statistic, so that's the same as what I just read in blue. But this time, I'm going to find its p-value using the table, and then I'll compare that to alpha. And the third option is I'll create the appropriate confidence interval, and I'm going to show you how to find the appropriate one, and see if the claim falls in it. And then, after I've done all that, I will do the interpretation, just like you were already doing for the confidence interval. So I'm going to write a conclusion, and I'm going to do it in context. I crossed out one of those arrows because I think that arrow was unnecessary. Alright, so now going back to problem 7, we're going to do this one first. So remember I had all these details, and I'm going to start with the name, and here's where you need to put it into your template. I'm going to switch over to that. And this template is being a butt for me, so I'll have to deal with it in mini version. Okay, so the name of the test, since I'm working with a mean, is a one sample t-test, because I'm going to have to use t since I have s sub x, which we learned in the last chapter. And my null hypothesis is that the delivery time, and remember I have to do it in terms of the population, so since this is an x bar, I'll be using mu, is actually less than or equal to 20 minutes. And the alternative, our guess, is that the mean delivery time is really greater than 20 minutes. And so now I'm going to add the words to that, because you have to have it in symbols and words. So there's my words. And now I have to check conditions, but we had already circled that it was an SRS, so we can put SRS stated, and we're going to assume that the population, in this case of all pizza deliveries, is greater than or equal to 10 times 35. And then for normality, we have a nice sample size. So since my sample size is greater than or equal to 30, I can say it's